So let's have a go at these questions then. First of all, question A. The time taken for a Formula 1 car to increase its velocity. So I need to rearrange the equation as I showed you before from that. I want to work out the time, so the first thing I need to do is multiply both sides by t. Okay, and that's going to cancel out, and that's going to give me t times a equals delta v, and then I need to divide that side by a so that they cancel out, and divide that side by a. So the equation becomes t equals delta v over a. Okay, now it's worth writing down what you've got. So look at the equation, look at the question and think, what do I have? Well, I've got the acceleration. The acceleration here is 7.5 meters per second squared. I don't have the time, and I also don't have delta v, but what I do have is the initial velocity and the final velocity. The initial velocity is 13, and the final velocity is 80 meters per second. So we can then start to put all these numbers into the equation. Delta v, remember, is final take away initial velocity. So it's 80 take away 13, because that's how we work out the difference between the starting velocity and the final velocity. And then we divide that by 7.5. Okay, so 80 take away 13 gives you 67. And then you divide that by 7.5. Okay, so if we put that into the calculator, you're just literally going to do 67, and then you can either press the divided by button or put it as a fraction, it's up to you, divided by 7.5, and that gives you 8.93 seconds. Okay, so there we go. Now let's have a look at part B. Part B is asking us to work out the final velocity of a man who runs with an average acceleration of 0.25 meters per second squared for 15 seconds. So let's start off this time by writing down what we've got. Well, we've got that a is 0.25 meters per second squared. We've got that t is 15 seconds. We don't have delta v, the change in velocity. We have u. It says that he starts from rest, so that means he starts from 0 meters per second. We don't have v, and that's what we're looking for, v, the final velocity. Okay, so let's take the equation now. A equals delta v over t. Now this question might seem confusing because that's not in the equation, but to work out the final velocity we need to know the change in velocity. So to work that out we need to rearrange this equation. So let's just section that off. So to work this out now, need to rearrange this equation to get it in the form of delta v. So you have to times both sides by t, and then they cancel out. Okay, so we know now that delta v, and all I'm doing here is just flipping the equation round. Then I know here we've got t times a equals delta v, but you can simply just write that with delta v on the left hand side and t times a on the right hand side. Doesn't make any difference, or even 8 times t makes no difference. So now we can work out delta v. 15 multiplied by 0.25. Okay, so half of 15 is 7.5. So half of that again, because we're looking for a quarter here, is 3.75, isn't it? Okay, so that's 3.75 meters per second. Now we then want to work it. So we've now got the change in velocity, okay, but we don't have the final velocity as such. However, we know that this car started off at 0 meters per second. Its velocity has changed by 3.75 meters per second, so that means its final velocity must be this. Okay, or to put it another way, we can do this. We know that delta v equals v minus u. Okay, so to rearrange this equation here, we add u to this side and then add u to this side. Okay, so minus u plus u cancels out. U plus delta v is equal to v. So again we can flip that around. V equals u plus delta v. So v equals u, which was 0, plus delta v, which is 3.75. So v is 3.75 meters per second. Okay. There we go. And that makes sense, doesn't it? Hopefully it makes sense anyway, because the change in velocity is the change from the starting velocity to the final velocity. And if you're starting at 0 and the velocity is changing by 3.75, then your final velocity must be 3.75. So there we go. Let's have a look at part C. Now for part C, again we're looking for the final velocity here. So we know that the acceleration is 0.15 meters per second squared. We know that the initial velocity is 8 meters per second, and we know that the time is 12 seconds, and we don't know v. So once again we can rearrange the equation to get delta v equals t times a. So t here is 12 and a is 0.15, so we multiply those together. Okay, now to work this out, 12 times 0.15, that gives you 1.8 meters per second. So far so good. So we've now got the change in velocity. This question's a little bit different because the starting velocity is 8 meters per second. The velocity has changed by 1.8, so you could now perhaps logically work out the final velocity. It started from 8, it's changed by that much, so what's the final velocity? But let's do this the full method. Okay, we know that delta v is equal to v minus u, final velocity take away initial velocity. So therefore we know that v is equal to delta v plus u, because I've shown you how to do it this way, but another way of thinking about this is if this is a minus u on this side, if we take it over this side it becomes a plus u. And then I've just swapped the equation around, okay? So all I've done here, just to show you, I've taken this over this side, so I've got v equals delta v plus u, okay? And then I've just swapped the two sides around. When a shortcut method of doing this is to say that if this is a minus u on this side, when you bring it over this side, it's a plus u, okay? And then you can just flip the equation around like that. And now I've got delta v, which is 1.8, plus u, which was, plus u, which was 8, and that gives me 9.8 meters per second, and there's my final answer.